Okay, so we have inverse functions here, and we need to talk about two tests before we talk about inverse functions. So a vertical line test, that will tell us whether a relation or a graph is a function, and that's if a vertical line intersects the graph in all places at exactly 1 point. A horizontal line test, that will tell us if a function is 1-to-1. So if a horizontal line test intersects the graph of a function at most 1 point, then the function is 1-to-1. A 1-to-1 function is a function since that each x value corresponds to a unique y value. So again, a vertical line test tells you whether it has a function, and then the horizontal line test tells you whether it's a 1-to-1 function, whether that function is a 1-to-1 function. So let's go ahead and do example number 1. It says determine whether each graph is a 1-to-1. In order for a graph to be 1-to-1, it has to pass the vertical line test and the horizontal line test. So let's start off with the vertical line test. I am going to go ahead and draw a vertical line here, and automatically here and here it touches the graph at more than 1 point, so it does not pass the vertical line test. And if it does not pass the vertical line test, it cannot be a 1-to-1. So not 1-to-1. Alright, so the next one, let's go ahead and do this. So we're going to go ahead and again start with the vertical line test. So let's do a vertical line test. And if I were to take that vertical line test, or vertical line, and move it left and right, would it ever touch the graph at more than 1 point? Nope. So it passes. We'll just say VT for vertical line test, and then we got to do the horizontal line test. So let's go ahead and do that. And you can see there, and there, that touches the graph at more than 1 point, so it fails the horizontal line test. So therefore, it cannot be a 1-to-1 if it fails either one. So not 1-to-1 function. So in order for it to be a 1-to-1 function, it has to pass the vertical line test and the horizontal line test. Just a quick example of something that does pass the horizontal line test would be this one. So here's a horizontal line, and if I were to move that line left or right, it would only touch the graph at 1 point. And then I could do a horizontal one, and same thing. Here, if I move it up or down, it would only touch the graph at 1 point as I move that line up and down. So this passes both tests, so it's 1-to-1. Alright, so next we're going to talk about inverse functions. In order for a function to have an inverse, it must be 1-to-1. Therefore, it must pass again the vertical and horizontal line test. And the first example we are going to talk about, it says find the inverse of the function of find the inverse of the function of the 1-to-1 function f equals 0, 1, comma, -2, 7, comma, 3, -6, comma, 4, 4. So notice they're already telling you that it's a 1-to-1, so you could already start finding the inverse. The way to find the inverse is you switch the x and y's on each pair, or on each point. So, and when you draw the inverse, you're gonna put a little -1 that stands for inverse, equals to. So here's the first one. we're just going to switch it to 1, 0. And then the next one, 7, -2. And the next one, -6, 3. And the next one, 4, 4. And that would be our inverse. Now, if I were to graph these points, they would pass the vertical and horizontal line test. So the directions to find an inverse of a one-to-one function algebraically, the first thing is to replace f of x with y, interchange every x with y and every y with x, solve the equation for y, represent y with the notation f inverse of x. So example number 3, we're going to find an equation of the inverse of f of x is equal to x plus 3. So in this case, we're going to go ahead and replace f of x with y. That's our step 1. So y equals x plus 3. And then step 2 is wherever you see an x, replace that with y, and wherever you see a y, replace that with x. Step 3 is solve for y. So I'm going to go ahead and subtract 3. So I get x minus 3 equals y, and then you're going to replace the y with f inverse. So f inverse of x is equal to x minus 3. Alright, and then that's it. So let's go ahead and do a graph. So graph the inverse. Now, this is not telling you that it's 1-to-1, so you want to make sure to check. Alright, so here it passes the vertical line test, because if I were to move this to the left and to the right, it would never touch the graph at more than 1 point. Alright, then let's do horizontal. If we move that up and down, it would only touch the graph at most 1 point, so it passes both, so it has an inverse. Alright, so now what I'm going to do is I'm going to erase these lines that I used, and I'm going to go ahead and find a couple of points that I could use. So here's this point down here, that's 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. So remember when we did the first example of finding the inverse, when we had points, we switched the x's and the y's. So I'm going to take all these points and I'm going to switch the x's and the y's. So 0, 0, 1, 1, those are the same. 2, 4, 3, 9. Alright, and then I probably need to extend this graph so that I hit 9. So we'll say 9 is there. Alright, so 0, 0, 1, 1, 2, 4, and then 3, 9. Alright, so there is the inverse. And if I were to fold across the line y equals x, which I'll draw in this red-orange color, they should be a mirror image of each other. So that's how you know if you did it correctly. And we're done here, and I'm just going to show you maybe one more example on how to find the inverse algebraically. Alright, so this one will say find the inverse of y equals square root of x minus 1, and we'll say it's a 1-to-1 function in the example, so I don't need to go ahead and do anything to test. So what we're going to do is step 1, it's basically already done because we already replaced y with f of x. That's how the problem was given. So step 2, we're going to go ahead and replace every x with y and every y with x. Alright, so next we're going to go ahead and have to isolate the y. So I'm going to add 1 to the other side. And then divide by 3, divide by 3, and then square both sides. And then 3 squared is 9, so I'm going to say 9. And then lastly, our last step is to replace that y with f inverse of x. And that would be our answer.